computer. So, hello everyone. Welcome back. Another week, another bi-weekly. My name is Eduardo for everyone watching, and this is our recording of our, I don't know how many, sixth sync of the reading club or learning club now, as we branched out and pivoted to multiple forms of learning at this point. We are back this week at reading the book. So this chapter, the book of AI engineering, and this chapter is quite long. So we split into two sessions. The first one being prompt engineering, which will cover this one. So I'll give, as usual, a quick summary of my point of view, and then we can discuss. So the first point is that this is how basically I see an LLM working. So a user makes a question, there's a response, but within the LLM, there are multiple specialists. There are multiple ways of answering a question. So you can answer a question about, is it a nice day? Either by talking about the weather, talking about politics, talking about, I don't know, the number of the day. And there are many options, and these are the options that and how to, like you can either rely on the LLM to decide how to respond, or you can help them respond a little bit better. From the previous chapters, this is this is about how fine-tuning works. We have the stock LLM, we pass on data, and we fine-tune. And then we say that is to say that some of the options is more likely than the other. So for example, we want to fine tune, we want the LLM to talk about weather. We're going to say, we're going to pass inputs and outputs for the fine tuning so that the weather type of response is more likely to happen. And the prompt engineering tries to achieve the same thing, but instead of like with the training, it concatenates a system prompt into the user question. So it changes the distribution of how likely an answer is to come by adapting the prompt itself. So this is where, for example, you add guarding rails. You should behave as you should not provide ethically ambiguous answers, or you should act as a developer or a journalist. This is how you guide the LLM to respond to the user question in a better way. And this is how basically every AI app has started at some point. So first of all, what are the difference between why would it choose prompt engineering rather than so prompt engineering is engineering over that original system prompt, and why would it choose prompt engineering over fine tuning? The good thing about fine tuning is that you don't need to worry about the context size. So all major models have a limit on how many tokens per prompt can be. This can be pretty large with Anthropic's 200K, or smaller with Mistral is 32K, but it depends on the application. And for example, if there are many messages on the chat, on the path of the chat, this can blow off quite quickly, the context. And fine tuning seems to be a little bit more reliable. Since you pass data, it's easier to guarantee that it will work. But it's a lot more expensive. Training a model is quite expensive, even at the fine tuning level. It's hard to iterate because it takes time to fine tune something. So you cannot just like keep trying new things. And it requires a lot more data, or at least more data than it is for prompt engineering. So you need to pass data for the model for it to be fine-tuned. On the other hand, prompt engineering is easier to try. It's just you pass on text, and that allows the LLM to be adapted. But it's a bit of magic, so there's no actual science on, well, we are trying to get some actual science on how prompt engineering works, but it is all empirical evidence. There's nothing like causal yet, or on how the mechanism of prompt engineering works. So it's a hit or miss. And if you change the version of the model, it might really change the impact of the prompt or how the prompt is read. We had this a while ago when we changed from Anthropic 2 and to Anthropic 3, and now we're having the same problem with when we're adding support for self-hosted models like Mistral and others. So prompt engineering means the prompt is engineered to that specific model you have. The other plus or minus, oh, this should be a minus. This is not a plus. Jesus Christ. This is a minus. It requires no or little data, so it's useful to pass some examples, but often you don't even any data for the prompt engine to be work. Another downside is that you always have to resend the system prompt. We have, for example, Anthropic is allowing to cache system prompts now, but in general is that you have to resend the system prompt, and this might cause the over time the cost to outweigh even like fine tuning. And as I mentioned, it's less effective on guiding the model, and it works, but it might not if the provider updates the model in the background, it might change something. So some of the guidelines that the book has presented is on how to better engineer prompts is to be precise and avoid ambiguity. So define really well what you want, provide examples of input and output. 1 or 2 or 3 should be enough. We call this N shot. So 0 shot is when you don't provide an example. N shot, 5 shot is when you provide 5 examples, for example. Specify the output format. So if it's consumed by human, so a human is chatting, it's okay. But if we are like using this as a tool selector on how to call a tool or how to connect with others, other front end or whatnot, it's better to specify the output format. This has a issue behind that. I linked a paper where it's discussed how asking the model to follow a specific format reduces its ability and efficiency, not efficiency, but ability and the outcome of the reasoning of the model. So it will provide worse answers following the format. And one of the proposed strategies is to have one piece of the prompt doing the reasoning and a second one doing the conversion to the decided format. The other one is to use personas, so act as a software engineer or act as a fourth grade teacher or something like, or a language teacher, some of those lines. There's also a few discussions whether that's actually useful. Some of the points is that this was useful initially for the early models, but it hasn't been as impactful recently. Another one is to break down prompts instead of having a huge prompt. Break down to smaller tasks, like, for example, specifying the output format that we discussed. First, have one that does the breakdown, that does the reasoning, the other does the breakdown. You can have the kind of behavior. Another one is to ask the model to evaluate its own output. So when you're writing the prompt, ask the model to think step by step, or to, at the end, give the reasoning behind their choice, or justify your choice, or something like that. This is called chain of thought, or COT. This, for some reason, helps the model on arriving at a more likely or a more truthful solution. Another point is to avoid scenarios that might lead to hallucination. So I have a very good, I have an example of this, which is Duo Chat. Duo Chat, on their prompt, at the end, they ask to include sources. But what happens often is that Duo Chat will just invent sources. Like, they are not part of the sources that were selected, that were part of fetching through RAG. It just invents one. Like, adding the sources should be outside of the prompt. It should be concatenated to the end of the response and not part of something you ask to the LLM itself. So that was that's another one. And for me, like like things that come to my mind is that prompts are very much like programming functions. They are the building block of how you build LLM apps. And each prompt should have a single responsibility. And the outcome of this, or the extension of this, is that you should be able to compose different prompts. So, for example, you want to output something as how do I say, like as JSON. So we could, instead of having every single prompt have like output as JSON, you could build the prompt dynamically and have like a smaller prompt that says output as JSON, for example. Prompts should also be testable and linkable. So we have a discussion of adding like English linters to our prompts so that we have a proper setup for them. And another cool thing that I found is that DSpy, which is a framework for improving and optimizing prompts, they market itself as a compiler for prompts. So similar that we have a compiler for functions, it's I found just interesting that they follow the same idea. And that was my my review of this chapter. And like, where do we want to go from here? What discussions do you have? What questions?
To me, one of the things that was interesting was the like few shot learning. So it's kind of in between your slide about fine tuning versus prompt engineering. It's kind of in between where you use the examples that you give in your prompt to actually train the model to answer similar questions better. And I guess that's one of the disadvantages of not having our own model is that it's up to whoever has the model to train on the prompts or not. But I thought that was interesting.
Yeah. And also these are not exclusive, like, right? You can fine tune and have the system prompt being added. That's actually what will happen very likely. I think we have some, especially on tool calling, we have, let me find it here. I think we have nshot on our thing. I'll see if I can find it. Chain templates. Some of here is like, for example, this is an example of what we want to do and how it should output the code. I think for tools we have in like issue reader, we have in more examples. Issue reader, prompts. Yeah, I thought no, but it doesn't look like it. I thought it was over here, but anyways.
Yeah. And then like I haven't seen having multiple prompts like running parallel in practice. So that sounds interesting to me. I'm not sure how that looks like. Is it that you have multiple prompts and you run them in parallel, so you make multiple calls to the model? But how do you combine things together? So say, for example, if you have a prompt, you mentioned an example of having a separate prompt for specifying the output format. Do you make one call to get the information, and then based on that, you have a different prompt together with the output and make another call to the LLM to get the format back? Or do you somehow combine the two into one call?
Yeah. Most common is the first option. Is that what we use as well in some places? So you first make a call to get the response, like the general response, and then another call for simplifying to a specific format. This is how we do, for example, with tools. We first send the user query, and then we make another query to format in the way that the tool wants to be used, and then we make the query actual for the tool with the tool response. With the like we combine both for the original response. We're gonna have multiple prompts being run in parallel. That's more agents, which is the subject of the next learning session, which is you have multiple apps, multiple LLM apps that defined by prompt interacting together. So you have one app that is responsible for planning and one that is responsible for writing the issue, another that is for implementing, another that is for code review. So it's more like an agentic behavior.
I think a good example of parallel of prompts run in parallel was the original implementation of GitLab Chat, because we summarized all the results in parallel, because it would be really slow to do that sequentially.
Yeah, yeah. If you have multiple ones. And another example for this is like, okay, we have the problem of the context window, right? That can be too large. One way to solve that is first ask the LLM to summarize the past conversation, the previous conversations, like the whole text, and then instead of saying the whole conversation with the additional point, just send the summary or the most important. That helps with context size. We haven't this implemented, but it is an idea.
Makes sense.
Does that help with latency if you're doing that like pre-processing and then sending a summary, or does that like make it worse because you're adding an extra step?
Yes and no. We can. It depends a lot. It might. It depends if making the secondary call is more expensive than processing a large amount of tokens. You can optimize this by when you request the response of the dual chat, we can already try to request a summary of the previous conversation. We don't hold all of the conversation. We just hold the summary at all times. You just like summarize the previous summary plus the new question. So this allows to reduce the number of tokens. If we reduce the number of tokens, that is likely to improve latency because it's less things to process. But it all comes down to the trade-offs. Even the answer is maybe, maybe not. Maybe this isn't necessary. For example, adding two sequential ones one for reasoning and one for outputting. That's almost for sure will increase the latency and the cost, because you first have to return a larger response and then you have to pass the response back and then you have to convert. So that is a little bit more problematic. It might be that the companies have an optimization for this down the road.
Yeah, and also I think for that, like summarizing the chat history and like the previous responses, I think something like that can be done in the background so that you don't necessarily have to do that during the request call. You can already summarize the previous response. And then by the time you make the call, it's already available. So that shouldn't add to the latency, but it will add to cost. Yeah.
Yeah.
This is more of an observation more so than anything in terms of like improving the response, like when prompting. So the concept of LLMs being forward thinking. So essentially like the last text being the latest context that they did have or that they do have. Yeah, I'm just curious to, like just asking, what your thoughts are around that. And if there are any other thing that one could add in terms of that approach to like improve the output or the response.
Yeah, it's like you mentioned, it's forward thinking. It's based on what you wrote. Like the current response will also change the impact of the next one. We don't have control over the response. We have control over the system prompt and the user. We might change the user prompt and modify the user prompt slightly to guide better response. or we might include more context. The book mentions a lot adding more context to the prompt to make it more definitive, more less chances of hallucination. Yeah. Cool.
Yeah, one of the things this chapter also really highlights, I was chatting to Dimitri about it, is you really need evaluation. Like all of this depends. Everything is just like the answer is it depends. And to experiment and like try everything. So yeah.
I think this is one of the respects I have for this book, is that they started with evaluation and then it moved to the application. I found that a very nice approach.
It's not an afterthought. It's like
the way to do it. Especially because people usually get bored after the application part, and then when they see the evaluation, they just don't join anymore. So at least we took it out in the beginning, and now we are going to the more exciting part.
Yeah. I love evaluation. To me, that's the exciting part. So.
Yeah, but ideally, in general, I think we want to spend the least amount of time possible in this prompt engineering part, because it's so, I don't know, magic. Like everything in this space is magic, and you're trying to deal with magic. But this one for me, it's like, okay, there was a prompt technique a while ago that if like being emotional, causing like emotional distress to the model. If you don't this, I will lose a finger every 10 minutes or something. And that actually increased the capability of the model. It responded better, which is that kind of stuff. Like, first of all, how do you came up with that? What was your state of mind at that moment? Like, were you so desperate? And the other is like, yeah, it works now, but then the model changes, and likely there won't be a evaluation. Like 90% of the case, there won't be a good evaluation set up to catch that, and it will just like fail. Works now, but who knows what will work later.
Yeah.
I want to explore this spy a little bit more, because I think I even had a POC of like adding LLM generated prompts or improvements prompt improved prompts to our own prompts. It's a very meta feature. But I think this spy could be something that we could use to improve the prompts that we have.
Can you ask a model to take a prompt and put it in a format that it would understand best? Like, has someone tried that?
Yes. Yes, this is for example, like right now, one of the problems we have on custom models is that we already support 5 different models or 4, and the number is going to increase, and each one has a different syntax almost. So how do we handle that? Because it's one prompt per feature per model, right? So this number explodes, and we need some way of automating that. So one thing I'm considering eventually is to have, can you please convert this to Mistral or whatever? We have Anthropic as the base prompt, and then we convert. It's likely that it won't work, but I think first of all, we need an evaluation framework to catch the ones that don't work, and second, if it does 50% of the job for us, that's enough. That's already enough improvement that we don't need to deal with the rest, as long as we have the evaluation test bed underneath. Right. Any more questions? Any more ideas? Otherwise, I'll close down.
Yeah, I thought this was a good chapter.
Yeah.
Go ahead.
I had one last comment to add. I wondered when, like along the lines of asking the LLM to reformat the prompt to be something that it would better use and give better output, how much is that necessary also every time we update our prompt, like from using Claude 3 to 3.5, and then whatever comes out next. I assume there's slight differences within it, and maybe Anthropic would let us know if there's any major changes to how you format the template. But behind the scenes, how much would that actually change, like our existing prompts? Could that cause huge degradation in our actual results given just their background change?
Answer is yes. When we migrated from Claude 2 to 2.1, there was a lot of work. Not a lot of work, but I know that some prompts, some features broke because the output was being generated in the wrong way, or it's not properly, like some of the tricks were not working anymore. And then it just didn't work. This is why evaluation, the test bed is important, because we need to be, it might be that it works. It might be that at some point that they're training, they're already adding those examples of how they need to behave, like to be like backwards compatible with folks' shenanigans, because that would be best. If I was a product manager, I would at least try to not break too much their stuff. So yeah, it was a case. I don't think for 3.0 it was too much of a problem, but for 2.1, I remember that it was.
And then that just kicks off a whole nother cycle of the prompt engineering of trying to fix the prompt so that it works the best for this one. It kind of feels never ending then.
And it's very complicated because sometimes you fix for one case, and by fixing for one case, you break for another. This is mentioned in the book as well. It's like a game of cat and mouse. You never know if you're fixing. This is the problem with the non-deterministic aspect of LLMs in general. You can never be 100% sure that what you're doing is actually correct. You need to assume that it's okay to make a mistake here and there.
Yeah.
Cool.
Evaluation.
Evaluation, even evaluation won't catch everything, and that's complicated. It's the same thing with machine learning. You can never catch everything. You actually expect some degree of uncertainty over there. And even if it is in the uncertainty, you don't know if it is because you did it correctly or because you are on the uncertainty of the uncertainty. So it gets a little bit meta and confusing. This is why I have yes, the problems that I have. Okay, we are out of time. I appreciate this discussion again, and we will have soon the second part of the chapter, and then we are out of chapters, and we will have to find something else to discuss. Thank you for joining for the time once again. Have a good one.
Thank you.
Bye. Thank you.
Cheers.
Cheers.